Here we go with part 2 of the 1.4 notes. So I'm on the page where it says division of radicals. So we talked about adding and subtracting. We talked about multiplying. Last thing is division. So example 17 and 18, these are already worked out for us. So we're just going to kind of see what's happening at each step. So the original problem has 12 divided by 3. And the first thing that happens is we put it into one radical. Combine into one radical. And I still have 12 divided by 3. It's just all in one square root now. And then what do? I actually do the division. I simplify. Because 12 divided by 3 is 4. And then we take the square root. Because the square root of 4 is 2. So let's look at this one. Square root of 7 divided by the square root of 63. Guess what? We did the same thing. We combined into one radical. Now it's the square root of 7 divided by 63. And again, I simplified. 7 over 63, those can both be divided by 7, which gives me the square root of 1/9. So we reduce the fraction. And lastly, we take the square root. Because the square root of 1 is 1. And the square root of 9 is 3. So the square root of 1/9 is 1/3. So knowing that, I would like you to try these next 3 problems. Follow the same steps. Combine it into one radical, simplify or reduce, and then take the square root. So pause the video, give these 3 a try, and then check back to see how you did. All right, for the first one, we combine it into one square root. 125 divided by 5 is 25. And 25 is a perfect square, and the square root of 25 is 5. Second one, combine it into one radical. When we divide, we get the square root of 3. Well, I can't do anything with the square root of 3. It's not a perfect square. I can't simplify it, so that's my final answer. Third one, square root of 18 divided by 8. I can reduce that fraction by dividing them both by 2, which gives me the square root of 9 over 4. And 9 and 4 are 2 numbers that I can take the square root of. The square root of 9 is 3, and the square root of 4 is 2. All right, moving on to, I guess the second example, 18. Just like with multiplication, we're going to do the outsides with the outsides and the insides with the insides. So I'm going to do 27 divided by 9, which gives me 3. And then I'm going to do 490 divided by 5, which, let me think, that's what? Is that 99? No, 98. It's 98. And then, just like always, we need to simplify. 98 is not a perfect square, but we can break it apart. 98 is an even number. So 2 times 49 is 98. And 49 is 7 times 7. So I have a pair of 7s and a loner 2. I still have that 3 out front. It's going to be joined by the 7. The 2 stays inside. And we get 21 times the square root of 2. All right, you know the drill. Pause the video. You try this one. It's just like the example we just did. All right. 24 divided by 6 gives me 4. 56 divided by 7 gives me the square root of 8, which we can break apart into a bunch of 2's. That gives me 4 times 2 times the square root of 2, or 8 square roots of 2. All right, last section here. there's kind of this weird rule, and it goes back a long ways in math, where we can't leave a radical in the denominator. We cannot leave a square root in the denominator. And to get it out of the denominator, we call this process rationalizing the denominator. We want to make it so that the number on the bottom of the fraction is a rational number or a whole number or an integer, something that's not like a weird square root number. So again, example 19 is worked out completely for us, but let's kind of see what happens. So I have 2 divided by the square root of 3. And again, I can't have it so that the square root is in the bottom. So this is what happens here. What do? We multiply by the square root of 3 over the square root of 3. So we multiply by, and this is what I want you to write, 1 in quotation marks. We multiply by 1. Now, 1 can be a lot of different things. 1 is 1, but basically any fraction where we have the same number on the top as we do on the bottom is 1. And the 1 should always match the square root in the denominator. So we chose square root of 3 over square root of 3 because it is square root of 3 that's originally in the denominator. All right, now moving forward, we actually do the multiplication. 2 times the square root of 3 is just 2 square roots of 3. The square root of 3 times the square root of 3 is the square root of 9. And then here I can take the square root, and now I don't have a square root in the denominator, so I'm done. All right, so let's try this one here. 4 divided by the square root of 7. My first step is to multiply by 1. And what does that 1 look like? Well, it always has to match whatever the square root is in the denominator, which in this case is the square root of 7. So I'm going to multiply by the square root of 7 over the square root of 7, which gives me 4 square roots of 7. Square root of 7 times the square root of 7 is the square root of 49, which I can actually take the square root of, and it gives me 7. Since my denominator isn't a square root anymore, boom, I'm done. All right, that is it for Unit 1, Lesson 4, and we'll see you next time in class.